What is the altitude of the point where the celestial equator crosses the local celestial meridian at latitude phi? First, draw the horizon as seen by the observer. Then, draw the meridian. Label one side of the meridian north and one side of the meridian south, because remember, the meridian is the line that goes from north to south. Then draw a line from the observer to the point on the sky that's the north celestial pole. Notice that the angle between the horizon and the north celestial pole is given by the latitude. This makes sense because at the north pole, the north celestial pole is directly above you, and at the equator, the north celestial pole is directly on the horizon. Next, draw a line 90 degrees with respect to the north celestial pole. Since the equator is 90 degrees relative to the north celestial pole, this line represents where the equator intersects the meridian. So you draw a line that's 90 degrees to the north celestial pole and then intersects the meridian. And this is the point where the celestial equator intersects the meridian. Now, the angle between the line from the observer to the north celestial pole and the line between the observer and the point where the celestial equator intersects the meridian is clearly 90 degrees, because there's 90 degrees between the celestial pole and the equator. So therefore, the angle between the horizon and the point where the celestial equator intersects the meridian has to be 90 minus phi, because only then do all the angles add up to 180, as you can see. So therefore, the altitude of the point where the celestial equator intersects the meridian is 90 minus phi. What is the declination of the zenith? So draw the horizon, draw the meridian, label it north and south, draw a line from the observer to the north celestial pole, draw a line from the observer to the point where the celestial equator intersects the meridian, and draw a line straight up from the observer to the zenith. Now, and then for convenience, draw lines on the horizon towards the north and south. So we know that the angle between the horizon and the north celestial pole is the latitude. And we've also calculated that the angle between the horizon and the point where the celestial equator intersects the meridian is 90 minus phi. Now, by trigonometry, we can see that the angle between the zenith and the north celestial pole must be 90 minus phi, because we know that the angle between the zenith and the horizon is 90. So that those two things have to add up to 90. And then, because the whole thing has to add up to 180 degrees, the angle between the point where the celestial equator intersects the meridian and the zenith has to be phi, the latitude. And by definition, since the angle between the zenith and the point where the celestial equator intersects the meridian is phi, the latitude, that's the declination of the zenith. Because declination is the angle with respect to the equator. And therefore the declination of the zenith is phi. What is the declination of a barely circumpolar star? So, of course, we're going to draw the horizon, the meridian, label it north and south, and we're going to draw a line from the observer to the north celestial pole. Now, a barely circumsolar star orbits the north celestial pole, but it touches the horizon. So that means that at its lowest point, it's on the horizon, and at its highest point, it's at an altitude of 2 feet, because the north celestial pole is its midpoint. So therefore, it must go all the way up to 2 feet. So draw the line representing the celestial equator, and we know that the angle between the point where the celestial equator crosses the meridian and the north celestial pole has to be 90 degrees. So if that's the case, then the angle between the point where the celestial equator crosses the meridian and the highest point in the sky that a barely circumpolar star gets is 90 minus phi, because that's the only way that those two things will add up to 90. So and that's the definition of declination. because remember, declination is the angle with respect to the equator. So the declination of a barely circumpolar star is 90 degrees minus the latitude. At what altitude is Vega barely circumpolar? Well, we know that declination of a barely circumpolar star is 90 degrees minus the latitude. And we know the declination of Vega is 38 degrees and 47 minutes. Add phi to both sides of the equation. Subtract 38 degrees and 47 minutes from both sides of the equation. Therefore, the latitude at which Vega is barely circumpolar is 51 degrees and 13 arc minutes. A telescope is located at latitude negative 32 degrees 22 minutes. The angle between it and the vertical is restricted to be between 31 degrees and 42 degrees, but its azimuthal angle is unrestricted. What are the possible declinations that it can observe? So, we're going to draw the horizon. We're going to draw, in this case we're going to draw the south celestial pole because we are at the southern hemisphere. We're going to draw the celestial equator, and we know that the angle between the horizon and the point where the celestial equator intersects meridian is 90 minus latitude. So in our case, 90 minus 32 degrees 22 minutes, which is 57 degrees 38 minutes. So the south celestial pole is at an altitude of 32 degrees 22 minutes because that's the latitude. Alright. So now draw a line straight up, which is the zenith, and we know the declination of the zenith is the latitude. We already calculated that. So the declination of the zenith at this point is negative 32 degrees and 22 minutes. And those other two purple lines that I've drawn, those are 31 degrees with respect to the vertical and 42 degrees with respect to the vertical. So because remember, the telescope can only look between 31 degrees and 42 degrees with respect to the vertical. So that's what those two lines are. The telescope can look anywhere between those two purple lines. So the declination of the first purple line, since it's 31 degrees south of the zenith, is simply the declination of the zenith minus 31 degrees, which is negative 63 degrees and 22 minutes. And then the declination of the further south the telescope can look is simply the declination of the zenith minus the angle from the zenith. And the declination of the zenith is negative 32 degrees 22 minutes. And it's 42 degrees south of the zenith. So the total declination, the furthest south that it can see is negative 32 degrees 22 minutes minus 42 degrees, which is negative 74 degrees and 22 minutes. So that's the furthest south the telescope can be. Now, just a reminder, the celestial equator has a declination of 0 degrees. So now orient the telescope due north and draw the two purple lines that represent where the telescope can look on the sky if it's oriented due north. And all we really need to worry about is what's the furthest north the telescope can see. Well, the furthest north the telescope can see is going to have is 42 degrees north of the zenith, because remember, the telescope has to be between 31 degrees and 42 degrees of the zenith. And so the furthest north it can go is 42 degrees north of the zenith, which means that its declination is the declination of the zenith plus 42, or 9 degrees 38 minutes north. So the telescope can see anywhere north of negative 74 degrees 22 minutes and south of positive 9 degrees 38 minutes.